Hello, everyone. Welcome to another episode of the Day Zero podcast. I'm Spectre. Joining me, as he always does, is Z. Also joining this episode is Auntie. Today is also a pretty cool day because we got partnered on Twitch today, so I thought I'd announce that little celebration before we get into topics. We have some very interesting topics this episode, including some drama around Google when it comes to nation states, some OAuth 2 hidden endpoint-based attacks, some C compiler optimization issues when it comes to undefined behavior, and a last-minute ad for PHP, which I'm sure some of you have probably heard about. So we'll kick it off with some drama. So Google ended up in a pot of hot water around their In the Wild series from Google Project Zero, which I think we've covered at least one of those posts on the podcast as a shout out, if nothing else.
And no, we've
Um,
we've covered four, I think. So like we covered the very first time they did a root cause analysis, and then we've covered and I think at that point there were 3 vulnerabilities, I think, and then we covered one root cause analysis on its own and one more post. So I think that gives us 4.
right. So yeah, there were some ethical concerns that were raised because while Google, with their threat analysis group, are fairly quick to call out ODAs found in the wild that were used by nation states like North Korea, we were kind of reminded of that with the North Korean hackers trying to hack hackers kind of topic we had not too long ago. But yeah, like when nation states like North Korea, Russia, and China launch zero-day campaigns, Google's threat analysis group is pretty quick to cover that. This time, they omitted the details of like who was involved and target details and stuff like that from the post, which I did notice, and I was a bit frustrated by it. I think we kind of chalked it up to, well, maybe they just didn't get a good understanding of who was involved, or there was, some internal reason why they couldn't get that information. But it
Well,
turns out that the operation that involved these vulns was launched by a Western government.
in fairness, usually like the Project Zero posts don't do that, attributing of the exploits to anybody. That, I mean, when we had the North Korea incident, that was the tag group, or well, threat analysis group that actually did attribute it to North Korea, not Project Zero. So we don't usually end up even talking about the attribution at all.
What I think people are pointing out though is usually when you have the Project Zero discovering the issues, you also have tag that comes out with the attribution angle, whereas with these posts that didn't really happen.
I
Right?
saw that, but I don't know if that's like, I saw some concern. I don't know. Maybe they're putting it somewhere else. But looking at the types of posts that Tag has put out, like they've talked about the North Korean group, and then they just have their kind of Tag bulletins every so often. Like I haven't seen them doing any sort of attribution. So maybe they do that somewhere else. Maybe they share that privately with researchers, like with threat intelligence. Oh no, Andy, since you kind of do more of the threat intel, would that be something that would get shared more privately or something?
I mean, it depends, I think for this, and I've only seen a little bit of backlash. I try not to get too involved and all that. But, when I think it was kind of said correctly, is that, Google doesn't seem to really like putting attribution on things, probably because of the fact that they're pretty much the most international organization. So it probably doesn't, go well when they attribute anything. What I did think for this, probably did let someone know. I would be surprised if they didn't at least say something. They didn't post, it seems like this was all the way back in October, right? If you discover a campaign like this, and especially the nature of what the exploits were, I mean, I think it was iOS, Chrome, and Windows, some very high value exploits, I would be pretty amazed if they thought, oh, this is probably just some guys from, Somalia. Like, I think they knew exactly who they knew that this was going to be more Western. So I'm guessing they did some type of deconfliction. And was it, and I can double check, did they actually release the initial one in their big blog series? I know there was kind of a few of them back in October. Or was this kind
No,
of their
this
big
was a
release?
more recent Project Zero post, I believe that this is about.
Because I would be curious to see if this is when they finally put it out there, if they kind of had to wait a bit, if they were this aware of it, and then just kind of were like, okay, we're going to give you some time to pivot here. I really don't know. I don't know how Google deconflicts, to be quite honest with you. I do know that it's obviously not very common. If a Western campaign was found, you would only see that with companies like cybersecurity companies who operate out of like maybe Russia or ones that aren't really as tied to Western agencies. Does that make sense?
Yeah, that makes sense. I guess more what I was trying to get at though was if you knew whether or not Google's normal kind of mode of operation was to share that information privately. Just because, like I said, I see people talking about how Google left out some information, but I'm not sure where they were actually seeing that information in the first place, like where it would have been expected, because we don't usually see that when it comes to the Project Zero posts. And as far as I can tell, like Tag might include that, but they don't have like a long history of doing so.
I think that that's more people in the industry getting frustrated that they don't get to use that information, if I'm being honest. And I could be wrong, but you know, it's one of those things that they don't have to release it all. To be quite frank with you, they could hold on to it and tell whoever they feel or tell no one. But from my point of view, I would refuse to believe they didn't let that information go to a handful of people, at least to confirm their finding, right? At least if this wasn't Western, right, and they are looking at that attribution, I would be surprised if they didn't want to let a few people know that, hey, there's this thing going on where they're dropping some pretty serious 0 days. You might want to investigate. No, I think that they've let people know, and anyone who's been let known is probably far more important than anyone lambasting them on Twitter. I could be wrong, but I think that's really it. I do think this is in line with what they do. I don't think they're ever going to really point out attribution because that's not what they care about. Anyone who's doing attribution, they'll just give that to the companies that typically do care about that.
I guess tying back around to kind of where the controversy was with this is that, just the fact that they did decide to patch these, or well, basically alert that these 0 days existed rather than just quietly sweeping them under the rug. They encourage getting these fixed and basically putting a stop to a Western operation.
So yeah, there was kind of two sides to the story. There were people who were upset because it felt like there were people protecting the identity of the perpetrators of the malware based on where it came from. There was also the other side that Z just mentioned, where you have people saying that Google getting these bugs rushed to get killed is bad because if it's a case like this one where it's being used in counterterrorism, then is Google standing in the way of counterterrorism? There is kind of that other angle to it too. I mean, I do kind of feel bad for Google here a little bit. This is a damned if you do, damned if you don't situation.
Yeah,
you're going to get people mad at you on both sides.
Yeah, there are definitely arguments on both sides. Like, personally, I kind of take it as let the governments doing that be a third party. They can bribe, they can coerce, whatever they want to do, but operating independent of the actual companies. I mean, there's always the concern. People bring up China and companies working with the Chinese government and being mandated to do so. I'm kind of in support of saying, if the government wants to get into the whole exploit business and targeting people that way, fine. But a company should have the choice to actively support that or not. I don't think Google's in the wrong for trying to protect the users rather than putting the concerns of the government ahead of that.
I mean, and to be fair to you, they said that this was a watering hole attack. So while these are normally meant to target specific people, did it ever explicitly say? I thought someone was saying that this was related to counterterrorism, but they actually explicitly say where this watering hole attack was conducted. I thought it was something.
I don't believe so.
Because that's the thing too, is if we don't have that information, what that watering hole attack means, is it in the best interest of they may be using it for that operation, but they could be using this for literally 100 different operations. So it is one of those things that it's easy to kind of go say, well, this is being used for the terrorists in this instance, but it's not like it can't be re-weaponized to go after anyone else, right? I feel like that's the hard part, is cherry picking the situation. Not that I'm saying, again, it's one of those things that you probably want to do. You do want to go after the baddie, so to speak. I think this really falls on whichever Western org, mainly for the fact that that's just the nature of doing business, right? I'm actually surprised it's not that they caught all these at once, right? It's that over time they kept discovering these exploits, right?
Yeah, I'm not sure
There were
what the
more
time
released over
frame.
time. Yeah.
Like, I don't think we get a clear time frame over how long it actually took them. They do say it was a high number of exploits over a short period of time. These 11 exploits over that period.
I think it was over like a few months span or something in 2020.
Yeah,
if I remember correctly.
So we don't have the exact details. They're being pretty light on that. And I don't think it necessarily matters over exactly how much it is, but it is enough that it was noteworthy that several vulnerabilities were dropping from the same, without attributing it, some APT, several vulnerabilities across, Safari browser on iPhone, various Google projects. There were some Windows CVEs out of it. So,
I mean,
across
but
all the big platforms.
What are you supposed to do though when those are literally targeting? I mean, pretty much everything that's
You could keep
concerning.
quiet. I do know people that have been asked to keep quiet about certain things. I won't go into details on that, of course.
Right.
But that it's not like that's unheard of. At the very least, that people have talked about that happening. Being tapped not to talk about certain types of vulnerabilities or certain vulnerabilities. So, they could just keep quiet. That's an option, and that's kind of that I guess is where the controversy is coming out of a lot of this is, Google's decision. Like Spectre said, it is a damned if you do, damned if you don't, because there's people on both sides of this, and there are fairly reasonable arguments on both sides. It really just depends on some of the external factors or opinions.
I mean, yeah, I don't know. You can't please really, honestly, anyone in the industry. There'll be literally people on both sides. Regardless, it is kind of funny though. I would genuinely hate to be part of any of this where you have to go and justify to one group or the other your decision, and one of those groups is going to hate you, and probably still a little bit of the other group, in any manner. So I very much sit on they kind of just did what they would have done anyways, but I can't really blame them. I think that when you're a APT group or whatever you want to label the Western group as, this is kind of the cost of doing business, in good or in bad. I mean, it's just something that happens.
You use an exploit, you expect it to get burned.
Yeah, so I guess that's where I'm at. Is I'm just, the only part I'm still confused at is because it was so many over just what sounds like a short period of time. Were they just throwing exploits at these, like this watering hole? And I don't know. That's the only thing I maybe should read more into. Is it just seems like so many high value ones in such a short period that were they just sitting there, and once one exploit stopped working, they just started bumping more through and didn't realize? Or that's the only crazy part.
It was just written to support the several different platforms at once. Because they didn't know what their target was going to come in with or something. I think we can actually find the RCA list. Pull that up here.
While you pull that up, I will say, something that kind of sucks here too is it's hard to have a super informed debate about it because there's still information that is just missing or being vague. We kind of touched on it a bit earlier, but they're saying, okay, these vulnerabilities were involved with a counterterrorism operation, but there's no details on that. They just throw around counterterrorism as if it means something. There's no there's some details where if we had that information, it would be easier to have a debate on that. But yeah, I think where it really falls, and I saw kind of that argument going around a bit on Twitter with the cost of doing business. I mean, if you're going to use 0 days, then you can't really complain when they get patched. I don't think it's fair at all to really blame Google for getting those fixed, especially where some of those issues in the Into Wild series, for example, they affected Android, if I remember right. A few of them did, and obviously it's in their best interest to make sure that Android is as secure as it can be for their customers. So I don't think it's fair to really rob them of that right for things, especially things like Chrome and Android where they own it. I think you can't really get mad at Google for fixing those issues. But even in general, even beyond their products, that still holds true.
And the other thing is, like, Google has at least a bit of a reputation of pushback against the government unless they come through like the proper legal process. So this is kind of just in continuation of that or in line with their past behavior. Like, I'm not sure if we have any examples of like Google Fiber, like their ISP cooperating, because I know a lot of ISPs cooperated with like the NSA. But
Mhm.
beyond that, like, generally what I hear about is Google having some pushback over anytime the government comes to them, unless they come with like a proper subpoena or whatever, like going through the proper process. So, proper process when you find out about a vulnerability, disclosure.
Yeah,
Yeah.
I think
Um,
that's I did agree on that one part though. That is a I think I didn't even think about is it is their products too, and you know I would be kind of irritated if someone goes, well, nope, don't fix your product, don't make sure it's safe. We need to keep using it. Well, I tell someone to eat shit too. I like that's a weird thing, regardless of the situation, to have to force on someone. To be honest.
yeah, so where Z has the list pulled up, it was only a few of them that were their products, like Chrome and Chrome for Android.
So
There
this
were a lot of
list,
like Windows and iOS as well on the list, but
yeah, and to be
there
clear,
were a few of
this
them.
this list is all of the RCAs they've done. This is not all of the vulnerabilities from that specific incident. So I was trying to look to see if I could correlate these by date and just say like the last 11, but it doesn't look like that's or by CVE number, since that's how they're ordered on here. But it's not clear that that's the case.
Yeah, so that's other information that we're kind of missing there too, is exactly which CVEs were involved. Um, but yeah, I mean, mainly what this topic headlines, I think, is just how much is being kept in the dark when it comes to like exploit stuff in general and its usage by nation states. Um, there's no like desire to really have a discussion around how ODAs should be used, when they should be used, if they should be used. Like they're just kind of being kept in the dark, which I guess it makes sense because of these are usually used in clandestine affairs. You're not, by definition, those are things that you kind of lock away in a box and never talk about. But um, it does cause problems when you like some political problems when you look at like situations like this, and it's hard to really get all the facts because nobody wants to talk about it.
Yeah, it's like we
Um,
don't really get to know much about what the rules of engagement are, I guess would be a good way of putting
that's a good
it.
way of putting it. Yeah.
Like, we don't know, we know that a lot of times where for like the actual military and when they're in conflict there, but we don't really know what the rules of engagement are when it comes to this privacy, except for some of the existing oversight. Although most people are going to be pretty skeptical of existing oversight over the intelligence agencies. Or I would expect you to be fairly skeptical of that because it's quite limited.
So I will quickly say, like, I'm not against the idea of like, governments using ODAs or buying them or whatever. I don't think that's like I'm definitely not against that. It's just it would be nice if there was that push to open for a discussion, but that can only really come from the side of the governments, right?
Yeah, I
So
mean, the reality is they're going to do it, whether or not we like it. Just like
exactly.
there's going to be military conflict, whether or not people like it.
Yeah, I mean, we just want to try to make sure that it happens in a responsible way, not stop it from happening entirely, because that's just not going to happen. Even if even if your country doesn't use exploits, another country is going to regardless. You're just putting yourself at a disadvantage, basically, by taking like that kind of moral high ground. So yeah, it's just there does need to be a discussion, I think, about trying to use that kind of stuff responsibly, like we've had with some of the previous advancements that have been made in the area of like war and engagement. But yeah, I don't know if or when that'll ever come about. But this is just kind of a supporting point to that argument that some kind of discussion should probably be had around that.
Yeah, I
All
mean,
right.
ultimately, though, like with this topic in particular, I think we're all generally in agreement that Google really isn't in the wrong for trying to patch the vulnerabilities in their own products or other products.
Yeah.
Yeah, that's probably the way to put it. Unless the government of whoever had those was listening, I fully support you. It's all cool. Please just let me live. But yeah, I don't think anyone realistically. Have there been a lot of people seriously though blaming like against Google for this? That was my only last point. Was it more or less from what you guys saw people against Google or for them in kind of this regard? Because I feel like most people
Most
I've
of
talked
what
to
I've
kind of
seen,
thought what I thought.
yeah, most of what I've seen, at least in like the security industry, has been more around just the fact that they didn't expose more information, like they actually did kind of protect the nation states a little bit. Was more on that side rather than on the side of like completely protecting them. It was the fact they did it at all.
Yeah, no, and I think the only grumpy people I've seen are kind of some of the goofballs that are angry that they didn't release more IOCs relating to it. But if it is like a, what's that, a counterterrorism thing, releasing the IOCs would be counterintuitive, probably, anyways. And
Yeah.
you know what I mean? Like it seems like that would be kind of a dumb point to even make, but also I think the idea was, if you release the IOCs, then there's something that people can do. But I just thought it was silly. I don't agree with that. I'm glad they didn't release anything like that. Not that they would have, but that was one weird point I did see some people make, which just is not necessary in something like this. And it wouldn't even matter in the long term anyways, So that was all. But yeah, I agree with everything you guys said.
All right, so we'll move on to our other interesting story that just came out yesterday around PHP. PHP's internal Git repository was compromised. They discovered 2 commits were pushed from developers that was not authored by the developers that the commits came from. From their internal investigation, they found it was likely that the server was compromised, not just the individual Git accounts. So because of that, they are now dropping using their own Git infrastructure, which it is a little bit questionable that they were even running their own Git server in the first place. Where PHP is so old, though, I can kind of see it just being a relic from before the hosted services were really a thing or really popular. So yeah, what they're going to remedy that, what they're going to do now to try to prevent those types of issues is they're going to make the GitHub repos canonical, and they're going to force two-factor authentication in order to be in the PHP organization on GitHub. They're going to continue their investigation to ensure no other malicious commits got through that they didn't see. But yeah, it's basically seems like it was a tried and failed supply chain attack on PHP, which
Perhaps.
is.
I'm not sure about that. Just because like they're very bold in what they do, and there is the one commit link. Let me see if I can find which one it is. But they actually add in the commit mentioning like pointing out a bug that was previously sold to 0DM.
It said something
yeah,
like
this
when they
one
pushed it, it was
here.
fixed typo, and they said something also. Yeah, they referenced 0DM or something.
Well, so
Which
it
one?
was 2 things. If the user agent included, I believe, might have been if it started with 0DM, it would execute the remainder of the user agent as since this is in the Zend code, I'm assuming these are also the like PHP bytecode, not actual PHP, like not strictly speaking the PHP code. I could be mistaken about exactly how like the Zend eval string works. It might actually run it as like a normal string. Either way, it was code execution if the user agent started with 0DM. But they also added in here this remove this sold to 0DM mid 2017. Which sounds
so
like they're
weird.
trying to point out a vulnerability that 0DM already knew about. So the other theory here is not that this is a supply chain attack, but that they compromised the Git server, tried to sell that access to 0DM, and of course that isn't something 0DM buys. They don't buy access, they buy vulnerabilities, which can be developed legally, not like an actual compromise of a specific service they don't tend to buy. Like you can't sell them your Facebook SQL injection. So it sounds like somebody might just got burned, been upset that like, oh, they won't buy it, therefore they're going to burn this or whatever. Like it sounds like that's kind of the other option here.
Could be like a revenge drop or something.
Yeah, and given the fact that they really call this out, like mentioning 0DM, making it really clear like that. It sounds like they're just trying to burn bridges.
That's an interesting angle that I hadn't really seen being mentioned, though this was like really last minute, so I didn't get to see too much of the discussion around this. But that is a very interesting angle, actually. I never even really considered that.
I mean, I thought it was really just like a troll move that like it might have been. I mean, the idea really, and I want to make sure I understand it, was this came about from they compromised through RCE, right? Is the belief kind of
We don't
right?
really know how they compromised the Git server itself.
Okay, because yeah, I thought I remember reading about it. And I thought it was through an RCE, which is why I thought it was actually funny, Vector, when you said, "Oh, they put 2FA," and I'm like, "Cool." The 2FA will really stop that RCE from getting through and regaining access. But um, I feel like this is one of those things that if you kind of look at it, I don't know if it's really related to even trying to burn a bridge. I feel like some of this could just be someone genuinely trolling that, when I'm sure when people are doing pen tests, they name all kinds of stupid stuff, dumb ways, and not that this is a pen test, but I assume in the same way that they were just trying to be kind of, cheeky about it rather than maybe actually burn it. But I wasn't aware of the one referencing the earlier, like 0DM. I already knew this type of thing. So it's entirely
Yeah,
possible, but would that not be a waste? Is that just a weird way to go about?
well, it's the fact
I
that
don't
they
know.
include that, the call out that this vulnerability, they say this was sold to 0DM, so I'm assuming there's some vulnerability in this code. It seems, that said, I guess that's in the added code specifically. Like now that I'm looking at it, so that does, sorry, my initial thought was that, they had just changed out. But now that I'm actually looking at the commit here, like we said, this is very kind of recently put out, so we haven't had a lot of time to dig into it. I guess that is something they added. It's not like they're pointing out the existence of a vulnerability. And out of chat, a root email asks user agent, doubt it would run. No. So it sounds like basically it's using the user agent as like the trigger for the backdoor.
Well, what he's pointing out is the agent has two T's in it. There's a typo.
Oh, didn't notice that. So it would just be a separate header then. It would be the header with two T's. Good point.
Yeah. So yeah, just a really weird situation. I don't think there's a lot of information out there about like, well, there's no information out there about like who the adversaries were or anything like that. Um, I don't know if we'll get more information in the future about like how the server was compromised or any of that detail. We might get it, but I don't hold out a ton of hope for that. Like I just don't think that's something that they'll really talk about publicly. They'll probably do their internal investigation. Um, and now that they've moved over to like GitHub or whatever, they're probably just going to wrap it up. But yeah, I mean, it's such a weird situation, and like you said, it is kind of a waste too, because like what makes this so weird is having this kind of access to the Git server for PHP development. You could slip in vulnerabilities, like if you mess with the commits and whatnot. You could try to slip in vulnerabilities or backdoors, and if you were smart about it, you could probably do it in a way that it wouldn't even be detected, and it would be like devastating to the security of PHP. But it's like whoever did this, like they wanted it to be loud and noisy. Like there's no way you do something like this, thinking that, oh, nobody's going to see this. Like it's too obvious. So yeah,
Yeah,
I mean,
that's
I do kind
why.
of fall behind that angle of intentionally burning it because it doesn't make sense otherwise.
Yeah, that's the same thing for me. Like, I think this is too loud to have been like an actual supply chain attack.
No, I mean
This is a
the commit
distraction to what
message
they're
was literally
really doing.
the commit message was a fixed typo, but I feel like if you obviously use Git, you could look at it and go, that doesn't look like just a typo. So I feel like you're right. I feel like if someone was really trying to make an effort to do exactly what you're saying, they would go a lot more in depth to do so. And it probably could have been with the access they possibly had even more done. But this does sound like something I could be wrong, and maybe I could look up real quick. But I thought there was a group that was going around and doing a bunch of Git hacking. I don't think they were compromising Git servers, but rather just like GitHub accounts of big companies. But you know, I think this is kind of a weird trend I'm starting to see of people go after actual Git either instances or accounts. I think it was the someone just got arrested for it. It was related to the camera hack. I don't know fully exactly, but there was that big camera hack, as long as Tesla, a few others that like basically their GitHub accounts were compromised. Um, and so I think it's in a similar vein. I think people are starting to look at this a bit more and go and say, like, can we pull something from this? But this still does feel a bit different. It's just such a bizarre situation, especially
Yeah,
with no attribution.
it's a weird one. I don't expect, like Spectre, I think already mentioned, I don't expect to see attribution coming out of PHP. That just doesn't really seem to be their wheelhouse, really, or security in general. A lot of the time, it seems.
Yeah, I mean, there's pods that have been out there for PHP bugs for years that like they don't even like care to fix or whatever. it's PHP is kind of a meme on the security angle. I will quickly touch on what you said though, Auntie, with in regards to like compromising Git repos. I mean, it is a very attractive target, and especially with like some of the new technologies that are coming around, like the GitHub Actions workflows. We actually have an issue related to that later on in the episode. But it's becoming easier to hit Git repos that are using those forms of continuous integration, just like leaking secrets through malicious workflows or having a template injection in workflows or something like that. So like there's more avenues to compromise Git repos, and like you said, I think attackers are starting to see the value in compromising those, where maybe before they were just kind of not really thought about or just kind of left nonchalantly. But yeah, it does seem like there's an interesting upward trend on that angle. So I
Yeah,
think that was good to
no,
bring up.
thought it was just interesting. And yeah, my guess is my last one point is, usually when people find something kind of dumb like this, a bunch of other people start looking for the exact same thing. So it's possible we'll see more, maybe not, who knows, but what a bizarre situation. So yeah.
Yeah, it's kind of a game of follow the leader in that regard. All right, so we'll move into our exploit section of the show. I believe, Auntie, you're probably going to jump out. Thank you for coming on, though, for those two topics. It's always nice to be able to have you on when we can. And yeah, any final thoughts before you hop off and move on?
Not many. I mean, don't run your own Git server. Only advice I can give, and I don't feel like I should have to say that in this 2021, but here we are. So yeah, don't run your own Git server. It's not necessary. Plenty of things out there for you. But that's it. I think that's all I've got to say. So I appreciate it, and I'll be on for the next one.
All right, awesome. Thanks for stopping by.
All right, you guys.
Yeah,
there we
I
go.
agree with K9 Team K9. Okay, I didn't realize you'd repeat K9 in there. Don't run your own public Git server. I think running an internal Git server is a bit different. Sometimes necessary for private corporations to be able to store some of their things privately.
Although, I mean, you do have GitLab self-hosted instances and stuff too,
where you're running a Git server privately, but it's still a Git server that you're running. Like, there are those options.
Yeah. All right, so we'll move into some of our exploits. So first we have some Chrome issues regarding the File System Access API. Nothing super interesting. Mostly like tricks with tricking the user into like what kind of file is being downloaded, trying to hide that information, for example. Unfortunately, the README on the GitHub and the video do not really explain the issues at all. But there are some comments in the POC files that explain them, and they do link to the CVE reports, which have details on the bugs themselves.
Do the CVs have details? I looked at a couple of them, hoping that they'd have. No, and it's just insufficient policy enforcement, and like they all insufficient.
If you follow
policy.
the CR bug links, they go to the Chromium bug repo where there's better vulnerability details.
Yeah, I just looked at the description there and was like, okay, we're not getting any information about these.
Yeah, so you do have to kind of dig a little bit to find like the info around the CVEs. Even still, they're not really super interesting. The repo itself consists of two different files. One file called show save file picker contains 5 CVEs that were patched in Chrome 88 and above, and the second contains 1 CVE, which is get file handle, that was patched in 89 and above. Yeah, basically the file with 5 CVEs, they were all tricks to try to hide the file extension, right? So they were like using white space and fake extensions to hide the real one, using RTL characters to delete the extension from the description or in the extension itself, using really long descriptions to try to get the extension, truncated or pushed off. Um, One of the more impactful ones, I think, was allowing shortcut files to get saved through the get file handle API, .lnk files. But yeah, it's mostly just like a set of tricks that were like edge cases that weren't really considered, I guess,
Yeah, so
in
they
the
did.
API.
They got a $5,000 bounty out of these, which is fairly decent for what it is. And I'll say, like, they're not that interesting. Like, I think a lot of us could have thought of the same sorts of attacks, but nobody actually went through and actually tried it. I think that's more kind of the aspect I want to go, is actually looking at something more obscure areas, I guess, and thinking about this sort of attack. Like, none of the attacks are really all that novel. Like, you're creating a large string to hide whatever gets appended at the end. Like, that's a pretty old attack. But still kind of interested to see that present even today.
Yeah, I mean, not only just thinking about it, but also having the fortitude to actually go through and test it. Um, there is this like common like thinking, and I've definitely fallen victim to this, where it's like you think this is way too stupid. There's no way this target would do this, right? I'm not even going to try it. Whereas if you do actually try it, you might find that it does actually work, and it could have like some impact. So I feel like people do that a lot. Like something like this, they would be like, "Oh, I could try a really long file name to hide the extension," but like they've got to do some kind of like stripping or filtering on that, or like length checking.
Well, but
But
what
it
about
just,
even thinking
yeah,
about trying to hide the extension in the first place?
yeah. I mean that's valid, but I mean there might have been people who have thought of some of these tricks without actually like thought they might work, but just never tested them. Whereas where this person went through and tested them, they confirmed that they were vulnerable and ended up getting that bounty. Um, Yeah, a lot of these issues though do kind of fall under that phishing category. Um, we still wanted to cover them though because these types of issues where they are a little bit more on the like weird tricks that some people might not think of aspect, we don't really cover them as often. We mainly cover like the technical logic bugs and stuff like that, right? So yeah, I mean it's a nice kind of change of pace, I guess, for the types of issues we cover. Um, but yeah, link will be in the description and whatever if anybody wants to check them out or see if those tricks work on their version of the browser. But it has been fixed on newer versions of Chrome. So up next, we have a HackerOne report, which is about HackerOne. It's limited disclosure. Unfortunately, I think all of our HackerOne issues today actually are limited disclosure. So that means we have a summary of the issue, but we can't go into the discussions we like to have sometimes about like the comments and back and forth. I
Well,
do really like when we get that,
I
but
think we kind of can, because there aren't a lot of options for this. Uh, so the issue is that on that interstitial page, so that's that page when you click a link. I should have had one ready to go to show, but when you click a HackerOne link, like in a report that goes to an external domain, it actually sends you off to like HackerOne slash I think it's redirect. I'm just trying to make one here. Yeah, this is the page. Redirect, and it has the URL, has where you're going, warns you that you're about to visit a remote page. What they ended up noticing for this report is basically that this page itself could be cached by like a search engine. So if it sees this link, it'll then kind of cache that. So if you did a search for something like, in URL, hackerone.com/redirect, you can find all of these pages that it's cached or that knows about that redirect to various pages. And of course, that URL might contain something sensitive, like a link to a proof of concept for a cross-site scripting attack or for some sort of vulnerability like that. So the fix was that they no longer allow the page itself to be indexed by the search engines. It was just adding that to the robots file. But I thought that was kind of a interesting way to get information about vulnerabilities. I'd imagine there's probably a lot of garbage. If you try that query now on Google, for what it's worth, that won't work as a Google dork. you don't get anything. I did try. Um, and at the same
Hackerman
time,
Z trying to steal secrets.
well, I was curious if it would still pull anything up. They do say that in most cases this is due to browser plugins and email software. So that usually comes down to something kind of reporting on. So root emails ask how would search engines pick up on that. It generally wasn't the search engines directly picking up. It's something else would kind of trigger it that then got it to pick it off because of the access, rather than it actually being able to scan and see these private URLs. But it was still it was an interesting aspect, I thought. Like, I would have never really thought to look for caching of those URLs.
It's something that you can easily, like, just skip your mind. So, yeah, like anywhere that had a link to like an external link to like a POC or an image or whatever could potentially get leaked. The fix was basically to explicitly tell crawlers not to index the page. So that netted them a $2,500 bounty, so not bad. It was a little bit interesting. There was some back and forth across like a while. Like the first comments started in like November, and we got comments all the way until like the date of disclosure, like into March. And the bounty wasn't awarded until March. So it does seem like a oddly long time for the issue to seem to get resolved. But then again, I am kind of speculating that that's when it was resolved, is when the bounty was paid out, because we don't actually know, where we don't have the comments or anything to go off of, unfortunately. But yeah, it's always fun to try to speculate a little bit when you have the dates, but you have that mystery of not knowing what was actually said on those dates. But
Yeah, it seems like some that could have taken a little while just to figure out like all the places that might have cached this information and all of the impacted clients because of that.
that could totally be the case. Yeah. But yeah, I mean, just one of those fun things that you never really think about. All right, so I mentioned earlier that we had a issue that affected GitHub workflows and could allow takeover of repositories. So we'll jump into that now. We have a few posts out of GitHub Security Lab. This is our first one, which is in a GitHub Actions workflow for geek-cookbook, which is basically a collection of recipes to run a private cloud, which you can use to host private instances of popular services like Plex Media Server, GitLab, stuff like that, right? And one of the workflows they have is the on push master notify Discord workflow, which, as it suggests, it will send like a message to Discord when a push is made. And it has a template injection. The issue comes into play is how they attempt to get the commit comment put into the Discord message. It doesn't do any filtering, which is problematic because that Discord action allows interpolation for environment variables for things like documentation. And that interpolation can be abused to get expressions interpreted as JavaScript when the template gets ran. So that can be used to get code execution in the GitHub runner instance. It can also allow someone who controls the commit message to inject arbitrary markdown into a Discord message, which could be problematic if they insert malicious links or something, but that's less of an issue than the interpolation angle. So yeah, basically anyone that makes a commit and can get like a pull request accepted, for example, could abuse this issue. And this was kind of cool because it showed a real case of a bug that the GitHub Security Lab itself has actually detailed as a possible attack in one of their previous posts. We did cover that post on the podcast. I meant to go back and get the episode number where we covered the research post where they talked about all the types of ways that you could have vulnerabilities through workflows, but I forgot to do that before the episode. So unfortunately, I don't have that episode readily available, but
yeah, like we've talked about this sort of issue like a couple times. It's just I think the other times we've talked about it has generally been just kind of in theory like this could happen. I do recall the one where you actually had the actions where you can add to the path, which is a little bit different from this one where it echoes from.
yeah, I mean, it's just like a cool showcase of like a real bug that uses a type of attack that we've seen before, or at least seen mentioned as a possibility before.
Yeah, this kind of comes down also just to how do you go about, like, obviously securely you process or whatever, but when you want to offer all this flexibility to just include random information, you're you're kind of left in this position where, like, you want to be able to include these variables so people can use that. It's just, JavaScript gives you this easy way of kind of doing that, except JavaScript also makes it extremely insecure by letting you also just call any function and do whatever the heck you want there.
It's kind of that insecure by design angle where it's hard to really draw the line of what is acceptable input and what isn't. Like, this is the kind of thing where you should only use this type of like interpolation on values that you absolutely trust, and you can't treat a commit message as trusted input. You might think initially that you could consider that trusted input because, well, people who are going to make commits into the repo are going to have access to that repo, but that's actually not true when you factor in pull requests. It would be like, if, to be honest, a maintainer should be able to catch if somebody tried to write a malicious commit message that would abuse this issue before accepting a pull request. But sometimes, maintainers just skip over that or miss it, or accept in a pull request because it looks like the code looks good. They just kind of skip past the commit message, and then it gets pulled in and they get popped, right? It's one of those things where
If you
I
hide it
think
in
this
a bunch
input
of
was trusted
commits,
where it shouldn't have been.
is kind of another thing. You send in a PR with a ton of commits, it can kind of be hidden in there a little bit.
Yeah, you
Root
can bury it.
email mentions the possibility of multi-line messages, might not be fully rendered depending on your UI. Yeah, those are options. Like, there are ways it's kind of hidden there. It is somewhat trusted, but like I said, there are ways through it. So it's still, a very legitimate attack.
Exactly. Yeah, so pretty straightforward issue, but it could allow for the compromise of a Git repo, which, as we said when Anti was on, that is a very juicy attack vector for an attacker that wants to pull off like a supply chain attack or something like that. Is to just go after that repo directly. Especially because a lot of repos, I think we talked about on this on the last podcast too, a lot of repos do automatically push releases for package managers too. So if you can compromise a Git repo, even if you can only compromise it for like a day or something, you could do a lot of damage. So yeah, gotta be careful on that stuff.
Well, I think this would more be compromising the runner itself, perhaps. Not necessarily the repo. I mean, when you get access to the secrets, you probably have access to something for the repository.
Yeah, you can leak like tokens and stuff like that, potentially.
But like this directly, I think the code execution would be on the runner, so the runner server, container, whatever it's running in.
Yeah. So we'll get into our next post, which is about HTTP2 over clear text, or H2C smuggling from Asset Note. It starts off by detailing what HTTP2 is compared to HTTP, which most people are familiar with. Basically, the fact that where HTTP connections are ephemeral, HTTP2 connections are persistent, and they allow that continuous communication. Z, have we talked about HTTP2 on the podcast before? I feel like we have.
We have talked about HTTP2 before. We have not talked about HTTP2 clear text smuggling, which was an attack that came out back early September. So it was just before we came back on the podcast after our break.
Right. Okay. I figured it had been a while because it sounded like it rung a bell, but I didn't remember when we would have talked about it. So, yeah, I mean, they talk about how the HTTP2 connections are persistent and can allow that continuous communication, which can be a problem if you're running a reverse proxy. Because the reverse proxy might think after your initial request has been processed and the connection is established that it no longer has to do any routing or checking of the rules or firewalls. So you're no longer bound to the rules of the reverse proxy the same way like you are with normal HTTP connections. So to try to prevent that, reverse proxies like AWS load balancers, Apache Traffic Server, Nginx, and some others, those are the ones they call out. They'll try to prevent the forwarding of those compliant upgrade requests. So in order to upgrade a connection to HTTP2, you have to send a header that asks for an upgrade and specifies an HTTP2 settings field. That's kind of outlined by the specification that you have to provide that. but there are some backends that aren't fully compliant to the HTTP2 spec. And in those cases, you could send a variant of the request that was non-compliant, so it would make it through the checks on the reverse proxy and make it to the backend server, and it would be interpreted, where normally it should be rejected if it were actually compliant. So for testing, they wrote a Golang
So it's
Golang based backend.
Sorry, it's not exactly that you would send a non-compliant request, because you would send a more or less like your request itself wasn't compliant. Where the whole clear text smuggling comes in is the fact that this upgrade, when you send the upgrade header H2C, that upgrade is only allowed if you're over HTTP. So if you're on HTTPS, it shouldn't allow you to do this upgrade to HTTP2. So the non-compliant servers are really where you have that reverse proxy in the middle. And so that reverse proxy will usually, or in many cases, will do HTTPS stripping. So it'll terminate the HTTPS security at kind of the edge and then pass that along to the actual server. And the server will think it's HTTP, or it will at least be an HTTP server. So they're taking advantage of the fact that the target server isn't going to know that you're using HTTPS, and that's where the non-compliancy comes in. It's just because like there are ways the target server could know that the source is an HTTPS. You can pass it down with like X-forward proto is a common header for that. So you can do it, but that's where the issue kind of comes in, is you can upgrade because it just doesn't know you're not supposed to be able to do it. Which then leads into, of course, when this vulnerability was first disclosed, and actually I guess I should include the link to that for anybody interested. The write-up for is from Bishop Fox, and it was a fairly good job at explaining, although this post, I mean, does a fine job of that too.
So I will say, actually, I thought the non-compliancy was more on the fact that the backend server should be rejecting requests that don't have the HTTP2 settings header. Because that is what, like, they focus on the services.
That is also non-compliant, sorry. That is kind of more where it comes down to, is when we get into the actual attacks, yeah, some of the servers will also strip HTTP2, so it'll include the HTTP2 settings header. It won't include HTTP2's settings in the like upgrade or connection headers. It'll strip it in one place, but not everywhere.
Yeah.
So that is also a non-compliant aspect.
So that's the one they mainly focus on with their testing. So for testing, they wrote this Golang-based backend, and they modified the H2C library to just accept an upgrade header without needing the HTTP2 settings that get stripped out. And then they tried using some popular reverse proxies and observed what would happen. So they found that Cloudflare would modify the header to exclude the settings, but it would keep the upgrade header. So that request would still make it through, and you would still get the H2C connection.
It would also include, so it would strip HTTP2 settings from, it would strip the HTTP2 settings option, so that's from the one header, but it would still include the HTTP2 settings header. You'll notice that here they talk about it including, yeah, however kept our other headers. It just modified the upgrade to exclude, because you include HTTP2 settings as its own header and as part of the connection header.
Which is just really weird. This kind of, like, I was going to kind of get into this after, but I'll bring it up now because it's relevant to what you're saying. This seems like almost misusable by design. It seems like very easy for this to be misused. I don't know why they're accepting it from multiple places like that. Do they actually...
They're not accepting it in multiple places. Basically, you can think of it as the connection saying upgrade, use HTTP2-settings, and then they go to HTTP2-settings, that's the header, and get the actual settings from the header. Like, they don't include the actual settings in that connection when it says upgrade. It's just like a tag or a flag saying, yeah, use HTTP2 settings.
Yeah. It's just, yeah.
So it's expandable. If you want it to have a different flag in the future, add something else, they can do that.
Yeah, I can kind of see the methodology behind designing it like that when you pointed it out. But yeah, like I said, it is like kind of easy to misuse that, and various services like Cloudflare in this instance did as well. Azure Access Gateway did the same thing essentially. And that can facilitate a global web application firewall bypass after you have that H2C connection established. Google Cloud Platform's load balancer wasn't vulnerable. They found that it would strip out all headers. So yeah, this is kind of a researchy type post. This was one of those things where they intentionally wrote a backend that was vulnerable and observed what would happen. They do say there were more cloud providers that were vulnerable to this issue, but they didn't disclose that at the time of writing, probably because those services are still vulnerable, still trying to fix it, or they just didn't want to be name dropped or whatever.
So is it that so maybe I misunderstood something here, because you're saying they wrote a server. I thought what they wrote was a client because like curl wouldn't let you do this because that was non-spec. Maybe they did also write a server and I just missed that.
Yeah, just looking at the setup field, they said, I decided to modify the original demo Golang server to accept these non-compliant HTTP connections.
Okay,
so
fair enough. And I just misunderstood where part of the issue was.
All good. But yeah, kind of a research post, but it does shed some light on this kind of obscure technology that I don't think a lot of people even are really aware of. HTTP2 over clear text. It's not something that is really used too often. So, or it's used under the hood and people don't even realize it's happening. So it's always nice to see research posts that shed light on some of those more obscure channels and attack surface related to that.
Yeah, and I guess, well, just as a kind of summary statement there, they did find Cloudflare kind of, we'll say, was vulnerable if you had a bad server. So was Azure. Google Cloud Platform would strip that HTTP2 settings header, so there was no way to upgrade. And Bishop Fox, when they did the original report on this, had tested with AWS, the load balancer there, which by default would not forward the upgrade or connection headers, so it was secure by default but could be configured insecurely. Just kind of a summary of where all of this impacts.
Perfect. Up next, we have some authorization bypasses in Google's Richmedia Studio, which I hadn't really heard of, but it's apparently an app that's used for running and managing marketing campaigns.
Neither had this researcher.
Yeah. So, this is coming out of Google's research grant program, and this was the target that was included. It seems to be a hidden app. If your account is not authenticated to be able to use this Richmedia Studio, you will get navigated away as if that page just doesn't even exist. But yeah, so the researcher looked into it. They ended up discovering 5 issues, 3 of which they cover in a deep detail. So the first issue they discover is an insecure direct object reference on media links, which is interesting because usually Google is pretty good with trying to prevent IDOR with their links, but in this case, they weren't. While the preview link looks pretty secure that they have there, and it uses long identifiers in the URL, the actual image link is much easier to guess. It only consists of a merchant ID, a date stamp for the upload, and a short random string of 6 characters. And I think actually it's 6 numeric characters, so the entropy is even more limited there.
Well, when I was looking at this, I'm not even sure there is necessarily randomness in it. So it's the merchant ID, as you said, and then the next set of digits is the timestamp. So what I'm seeing here is 2020, which is the year 1004. I'm assuming that's October 4th. Actually, given the date, yeah, no, I guess October 4th would be the one that makes sense. I was going to say April 10th, but that would have been quite a while back, so I don't know. Either way, that's a month and a day, most likely. We'll leave it at that. 04, 09, time 15, probably seconds. It could be that 15088 is actually 5 random digits, or it could just be seconds and milliseconds. Just because, I mean, everything else kind of fits with that. So I'm kind of leaning towards the possibility that that is purely just time-based. It's not even random. I mean, granted, milliseconds is kind of random, but...
I mean, the fact that it's purely numeric and it's not alphanumeric does suggest that it's not some random ID that's thrown in there. It's got to be like something time related. So I kind of agree with you there. That said, we don't know for sure like what the structure of that ID is because they don't really elaborate on it in the article. But mainly, like what's important there is that the link is guessable and it's fairly easy to generate. And because of that, you can access other merchants' uploaded images. So that netted a $500 bounty.
So it's guessable. I'm not sure if I'd say it's that easy though. So to be clear, I still think it's an issue. Like it's still a low rated, low severity issue. But you have to, like XSS ping.png or .ping, whatever. You've got to know the file name that they uploaded along with the exact time, or at least the exact date plus 5 random digits.
Which you could brute force.
You could brute force, but that is 99,000. Well, I mean, odds are let's just say 50,000 web requests. It's not like you can brute force it, no doubt, but that is a lot of requests to be making. And you have to know the file name. You don't have the right file name. If you have to guess the file name, that's 50,000 requests per possible file name per possible day. Just kind of splitting the difference, saying 50,000 is like, that's your 50%. Well, I'm sure somebody more knowledgeable in statistics will actually tell me how, because of whatever reason, it's not the 50%, but whatever. That's roughly half the requests. Like, it's a lot of requests, and you need to know that file name. I'm not sure if that file name can be leaked somewhere else. Like, if you could find that out because you saw the actual campaign that they ran or something, but, like, that is a lot of requests regardless, like, even if you know the file name. Like, it's not... this won't be considered a secure option. But actually brute forcing this in practice is also a lot of requests.
I do love the fact also, by the way, that the file name is XSSPNG. It's kind of funny. It seems like they were trying to use that image to potentially try to find some other issues. But yeah, second issue is a really strange logic bug, which leads to being able to access other users' campaigns. All they had to do was create a user with a role that doesn't have access to the QA dashboard. And then if they went to the QA page through a direct link, because it won't be shown on the limited account navbar, but if you go to it through a direct link, it would list the campaigns of all accounts on the service, which is just like really strange.
It's a nice finding. I can't
speculate
believe
as to how that happens.
Well, like they kind of say, a fail open situation. So you can kind of imagine a scenario where usually they would have like, what campaign is this associated with? And they'll just iterate. So let's say for each ID in list of campaigns they can read, do this. And then when they have none, it ends up just being a blank string rather than like the final query ends up being like where no condition rather than where some condition. I could imagine a scenario where this happens. I'm surprised that somebody at Google would do that, but I can't imagine the scenario.
Yeah, just really weird how that would have made it through like any level of code review. So this is the most impactful bug of the lot. This one netted a $5,000 bounty. Third issue was another IDOR issue related to file uploads. When digging into requests used for fetching file download URLs over the GWT API, they found there were 2 character IDs in the request, and these IDs turned out to be the campaign and file ID, and anyone could access any ID regardless if you're actually like authorized to that campaign or not. So that yielded another $500 bounty. They did find 2 other issues, but they didn't talk about them in the article. But yeah, overall, like not bad for the researcher. They netted $6,000 total in bounties. Issues were kind of trivial. 2 out of 3 were IDORs, and the other one was like a logic bug that was really impactful, but didn't require like any complex exploitation or anything to get to, which is a bit surprising. Considering this is a Google application, I kind of expected a stronger protections against these kinds of attacks. though this could potentially be like a revamped app or something, and that might have been why they pushed it into the research program. That would kind of make sense.
Yeah, I
My
mean
initial thought,
it's kind of a hidden application, so like it's not getting all the eyeballs that you would necessarily expect. Like I said,
yeah,
like I do definitely have a higher expectation when it comes to Google's code. Like they do have a good reputation. So like it's definitely surprising. But yeah, I mean looking at it, there's probably more vulnerabilities here for sure.
yeah, it looks like a potential bug farm. My first thought was, since we haven't really heard of this, and like this was put out in the research program, I was thinking maybe this app was kind of new and that this was in like a beta phase, and that's why it wasn't open to the public. But when I looked through like Web Archive, there's been references to this Richmedia app since 2013. So it just seems like one of those things where they just don't open it up to the public because it's meant for like, you know, a closed group of people that are invited. Um, but yeah, it does kind of remove that excuse I was conjuring in my head of why these issues might exist where it's early in development. Though, like I said, maybe it could be like a revamped app, or they went through like a major code base change or something. But that's just kind of my charitable take on why some of these issues might exist. It could be something like that. We don't know the internals of how this app is being deployed at Google, obviously, because you can't even get to it. So yeah, they're a little bit secretive about that. Up next, we have a binary issue in DD-WRT for routers. As you can guess, the issue is pretty trivial because routers. It's exposed through the universal plug and play functionality. They basically copy a UUID from a UPNP packet into an internal buffer of 128 bytes, but they use stir copy. Stir copy is a pretty commonly known sync because it doesn't do any length checking. So if you just pass a really long UUID, you can trigger a buffer overflow because it'll just keep copying until it sees a null byte, and you kind of control where that null byte goes. So yeah, this is just a case of don't use stir copy. Like at this point, a compiler should just fail to compile if you use these kinds of functions.
Well,
They're bad. There's no safe way to really use, unless you're using them on completely trusted data. There's no safe way to use these.
yeah, I mean some people do straight up just ban stir copy. Um, and yeah, the fix, as you'd guess, using stir L copy. I've included the link to the actual diff there. Like it's so UPnP, it's over UDP. There's no authentication here. The only authentication is, or at least slight saving grace, is the attacker has to be inside the network already. It does have to come from inside the network because this is used. Like you'll use this protocol to do things like dynamic port opening or port forwarding. You'll just send some UPnP packets and it'll tell it what ports to open up. But no authentication there, so pretty much anybody can compromise the router as long as they're already on the inside.
Yeah.
But still, just stupid issue. Kind of the usual thing. Static arrays on the stack being used as targets for those functions.
Like I said, just routers, dude. just routers. Now, they don't state it in the article, but this likely could be taken to code execution pretty easily. I very much doubt that they're using stack cookies because stack cookies are just so uncommon in routers and other IoT stuff.
So that's so this is in DD-WRT. So this is like an open source firmware that you can load onto it. So you're going to often, I don't know if you probably can get binaries for it because it's really popular, but you can also just compile this yourself. I'm sure a lot of people are going to compile this on their own too. And that's where you're going to define what security features you have.
Well, a lot of people are probably just going to use the default build configuration, though. So if that doesn't enable stack cookies, then most people are probably not going to have stack cookies.
Yeah, and I don't know what the default build is.
Yeah, so that's kind of speculation. We like to speculate on how likely you could take a bug to code execution when that detail isn't provided in the article. But I let's put it this way: I wouldn't be surprised if there were no stack cookies. And if you don't have stack cookies and you have a stack overflow like this, it's almost guaranteed you could take this to code execution one way or another. Now, it is worth noting that UPNP is not enabled by default because it is known to be kind of dangerous and impactful in its functionality. So that is a limiting factor, but that doesn't like mean this exploit vector is like impractical or anything. So, yeah, I mean, cool potential attack, but not a very cool bug. It's it's a very trivial issue. So we'll get into
in terms of
sorry.
in terms of taking this to code execution, I mean, you do have a straight up stack smash, but from that point, like you're getting, like you basically need another bug if there are any mitigations. If there are no mitigations, you can probably do this. Like you can almost certainly find like a pop ESP gadget or something to get your position of your shellcode, or at least something relative to your shellcode. So like, there's a reasonable chance that it could be exploited, and a pretty reasonable chance that even if there is ASLR or something, yeah, I guess the only saving grace would be canaries.
Yeah, that's pretty much the only thing that'll save you there. All right, so we'll get into our second GitHub Security Lab post, which is about glib, which is used for GNOME stuff. The issue is an integer overflow that's present on 64-bit platforms due to implicit casting inside the gbytes new function. And this function will take a size, and it will pass it to gmemdup to get a buffer allocated. But that function takes the size as a 32-bit integer, even though the g size that is given to the gbytes new function is 64 bits wide. So if you pass a really large value, it'll end up creating or allocating a really small buffer, but the size for copying in the data will use the full 64-bit size. So classic integer overflow due to type desync between the size for allocation and the size for use.
Well, yeah, due to truncation, I think would be the simple way of putting it. It's truncated when you pass into memdup, so it gets a small one. I love the fact, though, that they are doing kind of the right thing by keeping the size with the buffer. It just, you do get, as you said, that desync between it. Like, I think it's a fun bug.
Yeah. They do state they aren't aware of any exploitable vector for this. These types of issues are really hard to hit because you have to supply a super large size for the copy. So you have to be able to find a way to be able to stop that copy before it just smashes everything in its path. Like if you do a hex 1 and then 80 size copy, for one thing, you're likely to smash things that are important and are going to be used, and when they do get used, are going to blow up. Or what's even more likely is you're just going to hit unmapped memory, which is also going to blow up because you're going to segfault. So these types of issues are really difficult to exploit. You basically have to find a way to stop that copy midway through or something. But what this issue primarily shows is that some of these low-hanging fruit integer overflows are still out there. It's easy to think that they're gone now at this point because they are pretty trivial to find and discover even just through like fuzzing or whatever. But there are some areas where you can still find those.
Well, I think you should be getting a warning from your compiler with this too when you pass in the larger size.
Probably. It might just be one of those cases where they just ignore the warnings.
Yeah.
Yep.
I wouldn't be surprised about that at all.
Yeah, you just see hundreds of warnings and you're like, yeah, I'll deal with that later, maybe.
But yeah, I guess the other challenge, though, with this one, even with it being a large copy, is you need to understand the entire application to know where this is being used and where you can kind of pass something in. Because this is like a really fundamental, just G bytes new. Like it seems like it's a really kind of fundamental utility function. So it's going to be used in a lot of places where you may or may not have control over that size. So like even if there were somewhere exploitable, like it would be difficult to still find that yet. Where you have like, well, it may be difficult, I should say. I haven't actually looked to actually find the place where you do have the right amount of control over the bytes, and especially Spectre said, where this is such a large object that you're going to need a copy. A lot of these functions probably won't even read anything that large in the first place to be able to pass in or want a buffer of that size.
Yeah, so exploitation looks difficult, but I agree with you. I think the bug is kind of fun. So we'll get into a blog post from Realize, which details 4 vulnerabilities found in Qualcomm's secure execution environment. which could lead to compromise of the trusted execution environment of Qualcomm-based devices, which is a lot of Android phones, for example. A lot of North American Android phones use Qualcomm chips. They're reached through the secure monitor calls, or SMCs, that are issued to TrustZone, which you do have to have kernel privileges, as far as I understand it, to be able to send those. You have to be in
Yeah.
EL1.
Yeah, you need to be there, and it's basically like a syscall, except instead of calling to the kernel, you're calling to like the hypervisor, in this case, like the trusted environment.
Exactly. So yeah, they go to that trusted secure world applet, as it's called. Now, because these images are in secure world and they're meant to be like sectioned off, you don't have access to the source for these images or even symbols to work with, since it's a flat binary. So this article has a nice change of pace from many that we cover by approaching vuln research from a black box perspective, doing some binary auditing, where most of the issues we cover are found from source auditing. So yeah, like I said earlier, they found 4 bugs. All 4 are based on the same fundamental issue, which is taking untrusted pointers and just not validating them. And this happens in 4 different SMC calls. One was in the TrustZone BSP blow fuses and reset routine, which would take 2 arguments, an input pointer and an output pointer, for a binary blob. And when the input pointer is range checked, the output pointer isn't. So you effectively have a restricted write to an arbitrary address. It's not a completely arbitrary write because you don't control the data, but it still could be possible to exploit.
Yeah, and it's a very limited piece of data. Like, you could write either 1 or 2 to any address. And I will say, with a lot of these, the output is like, it's expecting a more or less not random, but it's expecting an address in the rich environments, kind of where your main operating system is running. Like, this is being used to get some data from the trusted environment out to the rich environment. So it's expecting just a pointer of some memory address. It just doesn't confirm that that memory address that you provide as an output buffer is actually part of the rich execution environment's memory, or you can just point it into the trusted execution environment's memory and kind of have your arbitrary write within there. But like, I just wanted to clarify, like, it makes some sense that's not doing a lot of validation, because all it really should be checking is if it's in that one range. Like, it's not going to have like a known really targeted area that the buffer will be.
It should be using like an API for the range checking, kind of like what kernel does, where it'll check the U limit, and anytime data is copied, it has to go through those official APIs.
Yeah,
it's probably
centralizing the
done
checks
here.
for sure.
Exactly. Now, like you said, it is kind of a restricted write with being able to write. I think you said it was 1 or 2. Now, while that does sound like really restrictive, I can already pitch an angle that you can use to exploit this right now. You would require an info leak probably to exploit any of these issues. You wouldn't be like, you would need to leak somewhere to write to inside of the trust zone, right?
How randomized is TrustZone actually?
I'm not sure on that. I've never actually really done anything in trust zones, so that is an interesting question. You might be able to like brute force it or something. But yeah, like, I'll pitch you an idea of how you could abuse this very restricted write. You can write 1 or 2. All you have to do is find an object that has a reference count in it. Then you find a reference count that has a higher value, you smash it to a lower value, and you trigger another bug. You trigger a use after free. And I kind of have a scenario like that for the next bug too, which was found in USB GLib. It had another pointer argument that wasn't range checked, and it'll write hex 787 to any address. Again, that may seem heavily constrained, but you could use this to do something like smash the length of a different object to trigger a more useful overflow. You can get a length set for an object that gets allocated, smash that length post allocation, and get a copy that uses that length, and you have an overflow. Now, these are just like theoretical attacks that I kind of came up with. They don't really elaborate and specify those attacks in the article, but I just want to point out, like, while these are restricted rights, that doesn't mean they're not exploitable by any means. There's totally ways you could take advantage of these. Third issue was yet another unchecked pointer in TZBSP version set. And the final one was, again, same issue, and I think it was actually a different function. In my notes, I have the same routine again, but I think it
No,
was
so
it
one
version
was
set
get
and
and one was set. So
oh right,
very
that was what
close.
confused me.
But,
In my
I
notes, they're both
actually,
set, so I was like, wait, what?
yeah, when I was well, so what they did here is at the top when they do the CV, they say 11.28 has version set and version get between them, but at the top of it, the SMC routine handler named _set, and at the top of the other one, they have the same name there. Like basically, both
That's
of them
probably
say
what threw
set
me
there,
off.
but the titles are what they get.
Yeah, that's probably what threw me off.
Yeah, they're a little bit more free in the rights, but we don't know exactly what type. They write the return value of a function, and they say that these arguments influence the return value, but they don't tell us how they influence the return value. So we don't really know what type of right you get out of them.
Yeah, you'd have to do some RE to figure out how you what you could set that value to. But yeah, just some really silly issues. Any user provided pointer needs to be checked, and this has been known for a long time now in things like kernels. It is a bit hard to believe that there was a proper code review conducted with these types of issues because these are very low hanging fruit. Like you said, this is the kind of issue that you just kill with centralizing into an API, which is what kernels have been doing for ever. So it is weird to see these issues, especially in an app you're running intentionally to be secure in secure world. And this isn't just an issue where one slipped through the cracks. This was found in multiple SMCs. There might even be more that just weren't disclosed in the blog post. But I mean, then again, this is Qualcomm. A lot of the issues we see from Qualcomm on this podcast are memes. So I'm not sure what I was really expecting, but I was kind of expecting the issues to be more interesting than they were. They were a bit of a letdown.
It's one of the first time. I think we've talked about some other trusted execution environment vulnerabilities before, but these ones, yeah, definitely are a letdown for what you kind of imagine it to be. That said, it does seem like the device, at least that they were testing, basically doesn't actually use the Qualcomm secure environment for anything relevant during runtime. They don't have any trusted applications, so not a lot you can do with this, but obviously this, the trusted environment is obviously going to be common across a lot of chips, not just this one device.
Well, even still, even if it's not using the Qualcomm secure world image, this should be able to let you compromise the chip that other images are running on as well. Like any other secure world application integrity should be broken, I think, right? I'm not 100% certain on that
But
because
there are
the
no
way
other
trust zone works.
there are no secure world applications being run.
Oh,
Is the
okay.
point.
I thought
It's
there
not
were other
doing
ones that
anything
could have been.
relevant.
Okay, fair enough.
At least
but
that's
yeah,
how
I mean,
it sounds to me.
But yeah, I mean, generally, compromising trust zone. If you compromise an applet in trust zone, you probably have compromise of that chip. So, yeah, pretty impactful issues, but not super fun issues because the bugs were kind of boring. But happens sometimes, especially with Qualcomm. So we have the last post in the Android full chain coming up on GitHub Security Lab. A few weeks ago, we talked about part 1, which was a kernel exploit. Last week, we covered a sandbox escape. This week is the awaited Chrome RCE. So we're coming to the end of a journey. This is the end of the 3-part blog series. So the bug here is a race-induced use after free in the audio handler subsystem. Interestingly, it was introduced as a regression in the beginning of 2020. This bug didn't used to be a thing, but then a commit in 2020 removed a mutex in the teardown routine. And they cited it as being safe to remove. And, well, narrator, it wasn't. Because while the patch did address the use after free possibility, it didn't consider the fact that it opened the function up to race conditions where an audio handler could be processed in the audio thread, while the teardown was removing the rendering orphan handlers on the main thread. And there's a nice diagram on the post, actually, which demonstrates what's going on. They have I can't take you down to the page, unfortunately, but it's the diagram right after before the mutex is removed, the audio handler is protected. They kind of show a window of where the race window is between the main thread and the audio thread. So it's a good visualization of what's going on there. So Yeah, the post goes through how they managed to control timings to exploit the race by using audio worklets that'll sleep. As far as I understand, you can use that to basically guarantee which race you want to hit. So, yeah,
Yeah,
that's a pretty cool strategy.
seems like basically the worklet like lets you provide JavaScript that'll run as the as that node within kind of the audio processing. So yeah, just sleep and you basically have complete control over exactly when things move on. And of course you control what node it's going to go to next. Yeah, lots of control here. I thought that was really interesting. Like actually for a browser exploit, this like the vulnerability itself was pretty clear. Like pretty easy to understand. They do mention that they hand wave a little bit when it comes to getting things scoped correctly because they don't want the worklet removed at the wrong time. So while they show some code, it was actually a little bit more complicated because they had to have a couple functions to change the scoping a little bit. But generally, like it did a really good job of explaining the vulnerability. The exploitation, though, I think you agree with me that was maybe a little bit wordy and kind of flowed all over the place as they talked about all the things that they didn't do and all of the options that didn't really work out. But
The
at least the
write-up was
first
kind of tricky
part
to
I thought
follow,
was
yeah.
good.
Yeah, so like you said, the vulnerability is clear. The exploit is like not trivial, like at all. And that's kind of the case with browser exploits in general. I find is the bug is uh, easier to understand, at least the basics of what it is, and then the exploit, like a lot of browser exploits, are going to be multi-stage, and this one is no exception.
Yeah, I don't
So
know.
I
Like
will.
our when we talked about like the turbofan issues, like those are just hard to follow even for the vulnerability.
That's true. But with browsers, I think the exploit is like the stage that's always like most interesting to me, and the most like difficult to follow. Um, yeah, I will quick touch on some of the exploit details. They note three different ways the race can be exploited depending on which timing gets hit when the graph of an audio handler gets processed. And this they detail under the controlling the race section. So they have point one, which is I have control of what code the audio thread will be running with a freed audio handler. To actually exploit this bug, I need to be able to control the race so when the audio handler is deleted. Um, that could have been used for hijacking a virtual method to get code exec while iterating the nodes of a UAF auto handler. But that would require an info leak, so it wasn't really ideal on its own. You would need something to pair with it. Um, the second point was they have control of what code the audio thread will be running with a freed audio handler, which could be used for like a type confusion to cause a different use after free. But that looked tricky to make it work with the path. I don't think they really explored that much beyond what they had in the initial paragraph they had in the article. Um, Point three was what they went with, I believe, for getting the info leak, which was hoping to replace the audio handler before the graph even gets processed. So they use this to get info leak by freeing the main graph without deleting the frame that contains it, which is useful because they can now replace the nodes themselves with sprayed data of whatever they want to leak, and they can leak them through those input-output nodes. The leak itself is fairly complicated and goes into specifics of different internal objects, which I won't go into here because I probably couldn't do it a lot of justice anyway. But essentially, they use the bug twice here. They use the bug for the info leak, and then they abuse the race UAF again to replace the vtable of the audio handler and fake it to an object they set up in the heap, and then they get code execution through one of the virtual methods called in the path when they trigger that bug. So this is a cool vulnerability, and it demonstrates how bugs in the browser, especially in the browser, can be full chained by themselves without even needing another bug. When I initially read this point about seeing like, okay, you can hijack a vtable or hijack a virtual method in a vtable, but you need an info leak. In many other situations, you would legitimately need a separate info leak to exploit that. But in browsers, because they're just such powerful beasts, um, it's more often than not your bug does allow you to derive your own info leak, and that's like really awesome, being able to full chain off one bug. And it's not because browsers are like simple or back in like the 2000s eras where that used to happen all the time. It's because browsers are actually so complex that they kind of benefit the attacker as much as they might benefit any technology that the browser tries to implement. So
Yeah, and I
yeah,
think part of that comes down to the fact that like a use after free is generally a pretty powerful vulnerability to have. Like there are plenty of cases where use after free isn't going to be too exploitable, but in such a complex system where you have so many options for what could be used, um, so like what reallocates it, like yeah, there's usually some way of getting that info leak when you have such a complicated system.
you have a lot of, I'm not going to say control, but you have a lot of influence on the heap state. So with
That
something like a
too.
parser bug, if you have a UAF and like a, I don't know, like a file parser or something, which would be kind of weird, but let's say you have one, it's going to be really tricky to exploit because how are you going to spray data when you're getting a file parsed? You might be able to, but it's going to be really tough. With a browser, you can like with JavaScript, you can get objects allocated at will, and you can control the lifetimes of those objects. You can control the data of those objects. You have so many options available to you when it comes to manipulating the heap state. So that's why use after freeze and browser and kernel kind of falls along the same line. Kernel with syscalls, you have a degree of control over the heap. Maybe not as much as you do in browsers, but yeah, I mean, it's just use after freeze are so powerful in browsers, and that is why we're starting to see moves where browsers are moving to um, strengthen heaps. They're trying to move objects into their own heap arenas, for example, so that even if you UAF an object, ideally they want to make it so you can't spray arbitrary data to take over that object. Um, but yeah, like there's a lot of work going into trying to strengthen the heap just because UAFs are such power. Well, any heap based bug is really powerful. UAF, overflow, anything like that, you can do a lot of damage in browser. So I will like say now that I covered the issue, like you said, the write up was not easy to follow. There were a few times where I essentially felt bait and switched because I read a paragraph all to find out that it was kind of irrelevant background info. They were like, "Oh, we're going to try this and take this path, and this is how this path works, and this could lead to this." And then it's like, "Oh, but at the end they're like, oh, we didn't do this because it wouldn't really work out." It's like, God damn it! It feels like there was a lot of like irrelevant background info. There's a lot of extra info here,
Yeah,
which
and there's benefit to that information. I think we kind of go back and forth. Sometimes, we'll talk about a write up, and it's like we like that they include this information. And other times, it's like this, where it just feels like it's an excess, and we would like them to kind of just get to the point.
so I was going to touch on that a little bit actually. Um, while we do usually like to see extra information, I think in this case it's very deterring, and the reason for that is in order to really take in this background information and be able to appreciate it, you have to have a lot of prerequisite knowledge on the browser and how it works. So, as much as that background info might be nice to have, I don't think it's going to benefit most people who are reading this write up unless they're like extremely familiar with browsers already. So, it just feels like one of those things that probably should have been left out, but that is kind of like, my opinion,
No, and I
maybe for
agree
other
with
people they
you.
agree with having
Or
that
in,
background info there.
or including just kind of a note like having more of a structured summary of it and then including extra information, or like having a summary somewhere, so kind of what's relevant or not when you start reading it. Because yeah, I mean, it takes up a lot of your time, for like the reader's time, to include a lot of the background information, which can be really useful if that's kind of the reader you're targeting. So like I don't blame them if that's who they were targeting, or the people that want that information. But just for us kind of reading through it, yeah.
Yeah, I mean, I guess where I'd pin it down to is um, I kind of had to work to find out what was relevant to the exploit. And if the write up was a bit more structured, um, and the write up kind of takes that work off of the reader, I think that's like really awesome to see. So, nothing, not to say anything bad about the vulnerability or the exploit. This is really cool work. And no doubt the background information is useful to some people out there. But just know if you're going to like go to read this after the show or whatever, um, you'll probably have to skip a few sections, like especially after the vulnerability is covered. Like primitives of the vulnerability and stuff, you might just want to skip and get to the getting an info leak. They have a getting an info leak first attempt. That section you can skip. That's a path that they tried and didn't work. So yeah, like getting an info leak for real is probably where you want to start reading if you're curious enough to get into reading the write-up. So yeah, good write-up overall though, and it was a good series from start to finish. It's I think I kind of said it on some of the previous posts in the series, but you don't always get to see the process into a full chain, like what goes into a full chain for like a modern mobile exploit. So being able to see all three parts thoroughly explained like that is I can't recall anything that's even close to it in recent memory that's covered like a full chain and that level of detail. So it's
I think
definitely
we've
worth checking out if you're interested in mobile.
um I think we've covered something. Maybe it was a Project Zero post. I don't recall. I know we've covered some other like full chain exploits too.
Yeah.
On mobile. That said, I did want to take a quick question out of chat, which was a root email asking about do you know any good tutorials for heap exploitation on Windows? The Linux heap is just so different. And you're correct that like the Linux heap itself is a very different implementation. Like it's generally a lot simpler than the Windows heap or Windows userland heap, backend, front end allocator. It does a bunch of things there that's different from what you'll see. That said, like the core concepts of the heap exploitation, like a use after free and all of that, like the fundamental concepts aren't all that different. It's the actual task of like doing the heap grooming, so creating space so you can allocate an object that you want, or what objects you can even allocate depending on how things get bucketed in the allocator. Those vary, and those are heap specific. But there's a lot of transferable knowledge when you know about the generalized heap exploitation. But that is kind of the other thing. When we talk about heap exploitation, there's heap allocator exploitation. And a lot of times when people talk about heap exploitation, they're actually talking about exploiting the allocator's implementation. So like all those house of attacks, all of those attacks are attacking the PT malloc allocator itself and corrupting that metadata, doing that. And when it comes to doing your heap exploitation, like there's kind of just the more generalized attacks like we talked about this one, where it's kind of dealing with the data that the application itself is using on the heap rather than attacking the actual allocator. Like the allocator in this case isn't all that relevant, except for the fact of it might have some checks for the use after free, might delay a free or something. Like if it had some hardening or something there, then there's kind of the possibility that the allocator becomes relevant. But you don't need all the internal knowledge, but it does help when you get to the actual like grooming steps and things of that nature. I don't know, Spectre, if you have anything you'd want to kind of add to that.
Yeah, I mean, kind of echoing that point. I see a lot of people who are wanting to get into heap exploitation and kind of tunnel in on those allocator attacks, and yeah, that is important to note that there is that separation between attacking the allocator and attacking just general heap data. And it's easy to conflate the two if you're like newer to it, because a lot of resources do for some reason. But yeah, like I think you covered it pretty well. I don't really have too much more to add on that front.
Yeah, and unfortunately, I don't have any good resource for like learning, like just heap overflows in general or use apt freeze, because really the only way you're going to do that is just start writing some exploits that involve it. Because ultimately, like it's application dependent. It's dependent on all of the application data. Or at least I'm assuming you're asking about that type of heap exploitation, learning about that, and not the allocator specific stuff, just because that's kind of what we're talking about right now. But if you are more interested on allocator specific, I also don't have any resource for that. So you can Google. There have been some good Black Hat talks. I just don't have any off the top of my head that kind of go into the Windows specific internals. Because like I
Yeah,
said, the Windows allocator is kind of a different beast.
yeah. In Windows, they have like pools and stuff. It's kind of a different world. That's the problem is with exploitation in general. Is there is some fragmentation where depending on your target, it's going to be very different. You're like no two exploit scenarios are alike, right? And that's what kind of makes it an art form. So yeah, we'll move on to our Project Zero issue of the episode, which is in Adobe Reader. It's an issue in their QoolType library, which is used for font rasterization, which is an interesting attack surface because it can be reached anywhere that an attacker can embed their own custom fonts. So, for example, in PDF documents, you can do that. There's technically two issues here, and it has to do with operations on variable fonts. And these used to be used by the older, like multiple master and newer variable master font or variable fonts. I can't talk too much on like the font formats because that's not really my area. I don't do font stuff.
Yeah, I've never heard of this, but you can kind of get the idea. Multiple master, there are multiple master designs as part of the font. That's kind of the key thing here that gets exploited. Or well, it's part of the calculations that get exploited. 'Cause this is effectively just overflowing the arithmetic. And by overflow, I mean not overflow in the sense of like wrapping it, but overflow in the sense of just going out of bounds.
Yeah. So in order to operate on these variable fonts, it has to operate on the PostScript stack. And it takes variables from the font to do so. Notably, two variables for this exploit, n and k. And n is the number of interpolated values on the operand stack, and k is the number of master designs or variables specified by the font. They then multiply n by k to access into that stack. So there's multiple edge cases that have to be handled here. Obviously, n cannot be negative or zero because n is supposed to be like you can't have a negative or zero number of values on the operand stack. It's supposed to you should have at least one. So it'll mess with the pointer arithmetic if it's zero or negative. K also can't be zero because if you're specifying a variable font, there's supposed to be more than like one or more variables. And anything times zero is zero. So you end up with zero values being popped from the stack, but n values being pushed back, and you kind of have that desync between how many are pushed and popped. The other condition you have to make sure of is the fact that the stack can hold a sufficient number of input values to satisfy n times k. If it doesn't, then you could end up reading or writing below the operand stack. So all of these edge cases are accounted for with the typical operator that's used, which is the blend operator or opcode 16. But they mention other operators on opcodes 14 to 18, which is called othersubrs. I'm not totally sure what that is. They kind of hand wave it a little bit. But in that case, the second and third conditions I mentioned are not checked properly. They never check if k is defined as a positive value, and the attempted check on the number of input values is broken because of a suspected typo. So in regards to the attempted check, they try to check that the OP-SP array at n times k is lower than the OP stack array, or in other words, that the access. They try to check if the access would extend past its own buffer, but this condition will never trigger because the OP-SP array access pointer will always be higher than the stack pointer. So as long as n and k are both positive, so it's just kind of this broken check. What they should have checked is if a negated n times k is lower than the stack array. It's suspected they just like forgot the negative or something like that. It was a very like easy mistake to make basically with how they're doing the arithmetic. So yeah, both of these bugs through different paths can allow out of bounds access. The first bug where they never check if k is positive is an easy exploit according to them. Because you can use it to smash the native thread stack and overwrite a return address or some other sensitive data on the stack and win. The second bug with the typo in the check, suspected typo, they think that probably isn't exploitable or would be extremely difficult to exploit because your size is very heavily constrained. And soon after triggering that bug, the interpreter bails out because it'll fail the third check since k is no longer positive. So yeah, you have kind of this one bug where it looks like it would be exploited. The other one, probably not. But both are very interesting bugs, I think. So yeah, in terms of timeline, they were reported December 17th and fixed February 9th. But it's just some of those fun logic bugs where they thought they had a proper check in place to prevent at least one of the issues, but due to an extremely small error, the check was useless. And we've seen that a few times before, but
Yeah, definitely. I mean, they're human. Developers are human, and the mistakes happen. Just, an old code doesn't get looked at a lot. It just kind of skips being examined, really.
yeah. And that's like the biggest problem, and the easiest way to get bitten is when, like, if somebody's doing code review and they see a check, it's easy to see the check and say it looks about right and then move on, like, okay, there's no issues here. And those are kind of the most dangerous, because if the check is implemented incorrectly or there's a very tiny bug there, it's very easy to go unnoticed. It's almost more dangerous than not having a check in terms of how obvious the bug is. So
Well, it reminds me of that one bug in eBPF where the calculation for like get max and get min were swapped when they did the copy and paste issue. I don't remember what episode that was on, but it kind of reminds me of that, where it's like there is a check there and it's really easy to kind of read that and be like, okay, it's, that seems right. In that case, it was more of a logical issue because it was calculating the wrong value, but just kind of reading over something and think, yeah, seems okay. Or even earlier when we were looking at the PHP thing, that user agent string with the double T that we didn't notice.
yeah, it's one of those things where you have to take a really hard look at it to spot it. So, and those are the kinds of bugs that are
fuzzing.
Or
I feel like this is something fuzzing would discover. Or could discover.
Yeah, that's a good point to bring up. But yeah, with that said, that'll conclude our exploit section. We'll move into our research portion of the show. Our first research post is from Microsoft's Vulnerability Research Lab with trusted types, and how they believe they might have killed cross-site scripting in most of Edge's WebUI pages. And WebUI is used for parts of the UI that are implemented with web technology, with like HTML and JavaScript. The settings page is an example of that they point out. And it's an interesting target because those pages have elevated privileges when it comes to things like camera and mic access. They can access it without prompting for user permission. So because those pages are so sensitive, they do have some defense and depth in place to try to prevent navigation to those scheme pages from regular websites. And those pages are also blocked access to the network. So XSS in these WebUI pages are usually treated as low severity. But the problem is, if someone has like a malicious or compromised extension, a compromised renderer could navigate to WebUI pages using a separate bug to exploit the XSS. They detail some XSS they found in WebUI. One was through histograms, which is used for telemetry. Funnily enough, the code indicates that XSS was a consideration, but they add a note to make sure that the input can't be controlled by a third party, which, while normally that is the case, from a compromised Chrome renderer, it might not be. The other case was SSL error pages also had an XSS through the URL parameter, though that only affected Chrome for iOS. It was kind of a target-specific issue. But yeah, after talking about some of the XSSs they've discovered, they also talk about how those could be exploited even with the restrictions placed on WebUI. For example, you could use it as an intermediate stage to try to leverage another bug in something like a sub-resource parser and like a chain for escalation. You could also inject a meta tag with refresh to navigate to like a phishing site. And some web UIs don't have an address bar, like I think they said print preview was one of them. So phishing would be kind of obscured in that way. Like you might not even know it's happening to you if that address bar is isn't being used in the web UI.
Well, isn't being used, or when it's not used, you can then inject your own spoof version of the address bar to make it look like you are somewhere legitimate.
Yeah, exactly. So something called trusted types was deployed a little while ago, which tries to force developers to not just be lazy and use strings for like input data, but they have to either use a safe DOM API So instead of doing like .inner HTML equals, which is the source of many of these bugs, they have to use like append child or something like that. Or if they don't want to use the Safe DOM API, they have to specify a trusted type policy, which forces input sanitization. But they mentioned that there's some ways that trusted types can be bypassed, such as like using non-DOM based API based
Yeah, so
script loading.
I kind of want to jump back and just mention like trusted types is something I've seen it mentioned a couple times, but hadn't really looked into this before. Especially like the trusted types policy, where you can actually include as part of that content security policy header, you can include a little bit about trusted types and tell like, hey, I only want like script sources or scripts to include trusted types. Which then means if they try to pass in like a string, like you might with inner HTML, it'll just fail. It expects you to be passing in, if you're going to dynamically create a script element, you have to use that document.create. You have to create like the actual DOM element itself and build it up, which generally speaking, like it can happen. They like, especially if you have like some script gadgets that you can maybe build up something like that. But in most scenarios, you're getting excess because of a string being used somewhere. So like it deals with really the vast majority of those issues, making it a lot more difficult to actually exploit.
Yeah. So
and then they make it even harder here with the perfect types.
Yeah, so that's what's new in this post, is perfect types. So yeah, like I said, like they could use like non-DOM API based script loading as well, and blob URL creation, as well as what you were mentioning with using script gadgets. But what's new here is that deploying of perfect types to WebUI by default, which is like trusted types, but it doesn't allow any policy creation. It's basically a stricter version of trusted types. So now developers can't use syncs like inner HTML ever. They have to use the proper DOM APIs. At the end, they summarize that not all WebUI pages can use perfected types because complex policies might be needed, but they are trying to reduce the number of pages that require those trusted type policies. But yeah, a key takeaway that they mention in this post is that the best form of defense here is ensuring secure coding practices. And like that's a good point, I think, to put out there. Basically, it's taking that angle of, okay, we're not going to be able to fix all, or we're not going to be able to mitigate XSS entirely from just trying to, make it so we do like maybe a bit of like policies or filtering or whatever. Let's make it so that developers can't be lazy and introduce these vulnerable pieces of code in the first place. And that is like a very valid angle that I think just in general, maybe even outside of just this XSS use case, there's been a heavy drive on mitigations for a while. Just kind of thinking, okay, screw it, we can't fix all bugs. Let's just work on mitigations so that those bugs can't be exploited. It is good to see some focus shifted on actually just trying to prevent bugs from being introduced in the first place. I think that practice is maybe being left by the wayside a little bit. So this was a good post, I think, to kind of highlight that aspect of
I really
defense
like
in depth
this
for
post
secure practices.
or exactly that, the defense in depth, seeing that, learning a little bit about the trust types and what's being done there, because it is a little bit of an obscure area that you're maybe not hearing about every day. Like, I mean, it even took forever for a content security policy to kind of get adopted. Yeah, I thought it was a well done post too. On a whole, like you're saying about kind of the mitigation aspect, and focus on there versus getting developers to write secure code. Like, people are never, I think, going to write secure code. We always need those kind of assists that frankly should be there, and I don't have a problem with that, but you need both, not just mitigations, not just secure development.
For sure. I don't think that like the drive on mitigation should be stopped. I just think there needs to be more of a balance. So yeah, we got to bring some balance to the
I feel like part of it is
force.
that developers fought back and it's like, no, we can write secure code. We can do this. And it's like everybody wants to write secure code, but nobody seems to do it.
Yeah, it's one of those things where it's like, if
Like,
you
you've
could
had your
write secure
chance.
code, you would have. Yeah, exactly. So, yeah, we'll move on to our next research post, though, which is another research post on OAuth attack vectors. This one's from Portswigger, and it focuses on OpenID Connect vulnerabilities, of which they found and detailed 3. So the first one is
So
a
they
server-side
detail,
request forgery.
or they
Sorry, go ahead.
detail the 3 vulnerabilities like that actually exist in Mitri ID and in the ForgeRock connectors. Oh no, ForgeRock something, and some other one in a couple implementations. But they also just kind of deal with, here's some things that you can be looking for if you're doing an assessment on a service that provides OAuth. So this isn't the client that like uses OAuth to authenticate with another service. So like, you can do like login with Google, login with whatever. It would be somebody that's providing that sort of setup, providing so like the Google or login with Discord or something. It's how you can test their OAuth server, which I thought was really interesting because they did dig into some things that I really didn't know about in terms of how it works. I'm pretty familiar with the client flow and like how the different flows work. Not so much with some of the backend things that maybe aren't quite so obvious. So I guess actually digging into them a little bit. One of the things they point out is this whole register endpoint. I guess a lot of them will have a endpoint that you can have to register your own client. So usually you need a client, so you can hit like a so you can provide the client ID so users know like who's asking for my information from this service. So it includes things like the appropriate redirect URIs, the logo URI, client name as you'd expect there, JWKS URI, so that's a JSON web key set, so being the key so they can actually validate if something's signed or not. Basically, there are a bunch of URLs in there, so Spectre was about to say server-side request forgery is kind of an option there because it needs to make the request to some of those URLs. It doesn't make it until you actually do a login in some case. So in Mitri ID, that logo URI that I mentioned, it'll basically proxy that to the user, which also means that you're able to get cross-site scripting through that logo URI because it doesn't enforce a content type header. But then they also suggest like you could look at getting server-side request forgery through that JSON web key set document that gets requested. I don't think they actually found that as an issue in the Mitri ID. Mitri ID was the application name, but it's at least an option. So that's kind of one of the things I appreciate about this. They provide a lot of things that maybe they didn't find, but you should be looking at if you're doing an assessment against an OAuth provider. So sorry, did you have something to add on there, Spectre?
Nope, that's all good. If you're going to move on to the second issue, go for it.
Yeah, I was going to move in. The second issue was with the redirect URI session poisoning. This one took me a little bit to kind of understand exactly what they were talking about. I don't know if it was just because I was coming at this from like the client perspective, and they're obviously not. They're talking about the server, and things were just getting really mixed up in my head. But the idea is pretty simple. Usually when you go through that OAuth process, you can imagine the scenario, you land on the page, it's like, you land on authorize or whatever, it's sending its client ID over the redirect URI so it knows where to send a user after you've like said, okay, yeah, they can have my data. They send you back with this redirect URI that includes the actual access token you can use or swap it out for your actual access token, I guess. So you kind of land on that page and then, it might need to log you in. So it'll show you the login form. And then eventually you reach the page that actually is like, here's the application. Here's the information they want from you. Do you approve this or not? So in doing that, some implementations may not pass in that client ID and that redirect URI. They may not pass that along with all of the requests and instead just store it in a session. That seems like a pretty normal-ish way to go and do it. Like that, nothing seems too crazy about storing the client ID and redirect URI just in the session. So when you actually do approve it, it can just look at the session and redirect you out. The problem is what happens if, when you're on that confirm page, what happens if a malicious website actually sends in another request to that authorized page? Like, so think like a CSRF attack. Sends another request there and swaps out those values in the session kind of right under you. So when you click approve, it doesn't actually realize that that changed, or may not. I mean, there are ways to implement it where it would be able to detect that, but swap it out from under you, and suddenly you've actually approved a completely different application. And then they send you off to this malicious redirect URI that got saved there, and they get your token. So I thought that was a really cool attack. Actually, like, all of these I thought were really interesting. I think a big part of that was the fact that I haven't done a lot of testing against an OAuth implementation itself. So yeah, I thought it was cool. And that one, did they find that on Mitri? Yeah, they found that on Mitri ID, using the Spring auto bind. They talked about another thing which has a mass assignment issue. So they didn't actually need to use the double request. They could just replace the redirect URI directly, but they talk about this as kind of like a thing in theory. And then the third one is part of OpenID Connect is that you need to have the web finger under the .well-known directory, which just lets you query for all the user information and makes all of that information well-known. They say makes it well-known, obviously play on the well-known folder. But what ends up happening is, you can think of this like any sort of normal user lookup, and they found an issue that I haven't come across in quite a long time, which is LDAP injection. So they found that in ForgeRock OpenAM. So that's what it was. So they found LDAP injection there, basically, because it's going to parse the host and username out of your actual web finger request. And there, you could also do some like SQL injection. They didn't find that. They did LDAP, but it depends on what the actual backing authentication system is. But it's, a place to look for that sort of issue. And I mean, LDAP injection, I said I haven't seen it in a while. I haven't, again, a lot of applications are, when I end up testing them at least, they're going to be deployed with SQL setups behind them, usually not LDAP, until they're actually in like a production deployment. So I haven't run across it, but it's not like it's some secretive vulnerability or something. Either way, there were a ton of interesting issues here, and they just talk about a ton of possible issues. So, like, I found the whole thing interesting, but a little bit difficult to read.
Yeah, I was in that camp as well, and I think it just comes down to the lack of experience in OAuth. Like, I haven't even really used OAuth much from a client perspective, like implementing it. It does seem like OAuth is kind of the new kid on the block when it comes to attack surface that people are starting to really look at, because it is such a complex it's a complex state to try to keep track of from the server side.
It's easy
for issues to spring up.
SAML's, the more enterprisey thing that you might use for this sort of single sign-on system. OAuth is, at least from the implementation aspect for the client, a lot easier to do.
Yeah, but it's just because the state is so complex to track. It's easy for like issues to slip through. So we'll probably be seeing more and more OAuth stuff as time goes on. It seems maybe it's just a recency bias where we've covered it like last episode and this episode as well. But it seems like in general, there's kind of that upward trend of seeing more and more OAuth based issues pop up.
It's definitely a juicy surface. So yeah, I'd imagine we'll see more fairly soon. And yeah, I think it's a good follow up from our last week one too.
Yeah, it was cool to be able to do like a back to back of that. All right, so we'll get into our last topic of the episode here, which is the future of C code review. Now, this isn't really a write up. It's kind of a medium that we don't cover too often on the podcast, but it was a presentation which talked about like optimizations and compilers and how they're getting more and more aggressive over time.
Well, it talked about one particular optimization, which is what they refer to as this pointer provenance based alias analysis. What is that? The example that they give, and I mean, reading that, like, I can kind of reason maybe a little bit about it, like it's reasoning about what it knows about the pointer provenance based. Like, you can kind of get something. The basic idea is, in writing C code, you use a lot of undefined, or a lot of people, maybe not all developers, but a lot of developers will use undefined functionality. They'll use that kind of assuming that the C compiler is just going to pass it through to the hardware. So like if you take a pointer and you add 1 to it, you expect that pointer, you expect like either the normal pointer arithmetic, you expect that to be pointing just kind of to the next space in memory, no matter what that is. So if that is another variable or what it is, doesn't matter. So what this one talks about with this pointer provenance-based alias analysis is the idea that when you do that, it might still know. So they have the example code here, int p, or I will say they declare 2 integers just on the stack, or in global actually, y and x. So then they create a pointer on the stack, int p, or int star p, so pointer p, that points to x, the address of x plus 1, and q, which points to y. You would expect x plus 1 should point plus 4 bytes, assuming a 4-byte integer pointer arithmetic, should point to the location of, I guess that should point y. Maybe I'm going crazy here.
Yeah, it should point to y because they should be adjacent in memory.
Yeah, should be adjacent in memory. So what happens with this alias, or with this optimization basically, is the compiler will be aware that, hey, you're accessing X. You're accessing something offset X. So it'll treat that as completely different from Y. So even though you do an assignment based on some of those values, and they do this in other code. Unfortunately, like the frame of the video doesn't show everything, but you'll do an assignment and you'll kind of expect it to be assigning it to whatever's in Y. Whereas the reality is it's going to treat it as some completely separate assignment and take away that directness or that reflection of what the hardware's doing by just assuming it's something completely different. Like, of course, they're accessing X, so it's not Y. It couldn't be Y, so they can make that assumption in their optimizations. So that's the specific case that he talks about in this presentation. In general, he's talking about just over time, compilers seem to be pushing more for performance and less for keeping up with some of those more concrete semantics of how the hardware is actually working, and less guarantees about what like the memory's actually going to look like. Which I thought it was a really interesting, because it's definitely going to make doing C code review a lot more difficult when you can make some of these assumptions that for years we've kind of just assumed C's more or less reflecting the hardware, even though that isn't actually the case.
So I have a bit of a question for you here. On this specific issue, who would you blame? Would you blame the code author, or would you blame the compiler authors with their optimizations if this blew up on you?
You could blame both, because it is undefined functionality. The compilers are allowed to do this. It's just for a long time the compilers haven't done this. And so making this change over time, it's creating a lot more, it's becoming a lot more difficult even to reason about security of the code when they make these sorts of changes. I mean, it's not that compilers can't do it, because like it is, as I said, it is undefined functionality. Like they're allowed to implement a game of chess after you do this if they really wanted to. But generally speaking, they don't do that. They don't surprise you like that. And this starts breaking that law of no surprise. So that's kind of where I'd want to put blame on the compilers. I mean, obviously they are allowed to do this. It is an optimization. It makes it a lot more difficult to reason about code when you can't trust the compilers actually kind of working with your normal understanding of memory.
Yeah, I mean, that's the thing, I guess. With C's target audience, it's kind of expected that you're going to know how your code is going to translate into the hardware, like where things are going to be roughly in memory. Like if you see a structure, you're going to know, okay, this is going to be next to this, and it's going to be this many bytes away. Maybe not the exact amount, but you know roughly how things are structured in memory.
Yeah, like you
taking
can reason
away that
about
assumption.
it.
Yeah, taking away that assumption after the fact is like you're kind of getting switched out by the compiler, and it's kind of like breaking your assumptions, and like you said, like you don't really expect it. And I know people, and I myself actually, just disable optimizations entirely because of not this specific issue because this was new to me, but other issues that are induced by compilers. So you just don't want to deal with. So instead of dealing with optimization, you just cut it out entirely. So yeah, it does seem like optimization is getting a little bit too aggressive, perhaps. Um, and there is kind of that desync between how like different compilers will optimize it. So yeah, it's kind of an unfortunate situation, and like you said, I could see blame being placed on both. In this specific case, um, it does seem, while I
This
would
is a
say it's,
contrived case, so I don't really want to judge this specific one because this is the case meant to showcase exactly the issue.
yeah, so
Like they're doing
that,
something really weird. You're not going to do that, but you might do that knowing like, okay, I've got an array here, and now here's my element to the array. I'm going to, add the size of the array and just get the next element without actually accessing it through the array.
but
Would
you
be
do kind of need that aspect where you're overflowing your array, right? You need to be accessing or overlapping with the pointer of a different object,
well, so
which does
that's
kind of put the blame on the developer, right? You
but
should be making sure you're not extending past your own data.
well, so here's what I'm saying. Say you have two variables, one that's an array, one that is an element or pointer to an element inside of the array. Increment the pointer. So let's say it's an array of integers. Increment the pointer, or say jump 2. So you want to do your pointer and then +2, address of the pointer +2. Because you're accessing that pointer, it no longer recognizes it as part of that array necessarily. It very well may recognize that this is a really trivial example, but you're doing the access just on the element and adding it there. So it's seeing it as completely separate from your pointer to the actual array structure, and thus may optimize it thinking that they are different objects. And I do think that the access to a particular, like incrementing a particular element of an array, like the pointer to an element in an array, is a reasonably common thing.
Yeah, yeah, especially in certain code bases.
Yeah, and in fairness, I don't totally understand exactly how this works, so maybe that one wouldn't actually get optimized. There is like this 30-page document about this whole memory object model to look into that you can read if you want to kind of understand it more. But in general, though, it does make the code review harder when you lose some of that foundational mental model of kind of how the computer works.
Yeah, it's kind of funny with this case. There was a defect report filed for it, and it was brought up. Like the issue was brought up with the abstract model, and the 2004 committee stated that it was fine, basically, to do this, but it was never actually incorporated into the standard. So that's kind of where you got this issue where different compilers are treating the code different ways. Um, yeah, so this is an interesting issue. I would definitely recommend anyone who like is interested in like the lower level stuff to give this talk a listen. It is pretty short at like 20 minutes. Um, Now, like you said, this piece of code in these slides is a pretty contrived example. While it is certainly like interesting and worth noting and discussing about like we are, I am kind of struggling to see like I can't recall ever seeing a real world example of this type of issue manifesting.
No, and neither
Um,
can I. I actually commented asking if he knew of any. I haven't gotten a reply on that, so hasn't pointed any outs. Yeah, I don't know either, but that's where the talk is the future of C code review. So it's just like, needing to review code with this in mind that these things are going to happen and more optimizations in general. Not necessarily this specific one, but yeah, I can't think of any cases where this has actually been the source of a problem. But that doesn't mean it can't happen or that it hasn't happened, just that we don't know about because this would be a really subtle bug.
yeah, this bug was kind of used as a vehicle to talk about like optimization in general and how we have to be careful with it going forward. Um, but yeah, cool talk. And yeah, like you said, like if you were doing code review, you're not going to factor in what the optimization is going to do because you're not going to know.
Yeah, and this
Optimizers are very, very complex. They're not like easily deterministic from like a source code perspective.
yeah, and this is still something you could find with like analysis of the binary itself, fuzzing, dynamic testing. Like if an issue were introduced from this, it could still be discovered. It's just specifically for code review. in theory, you could have some code that looks fine that gets optimized in such a way that it isn't.
Yeah, it shows why that dynamic testing still has a lot of value, even if you have strong source auditing in place. All right, so that's pretty much all of our topics. We do have a shout out as well from
Actually,
Project
two
Zero.
shout outs.
Oh, do we have two? We have a last one.
Well, I didn't add one to the list. I forgot, but the first one here,
All good.
one of the root cause analysis. We talked a little bit about the Microsoft Exchange stuff and the vulnerabilities there. We didn't dive into the details of the vulnerability because we were waiting on. They said they would release a paper with like the technical information about the vulnerabilities. As far as I'm aware, that hasn't happened yet. There have been some other write-ups, but also Project Zero has released one of their in the wild write-ups about the server-side request forgery. I really like these RCAs that Project Zero does because they're concise, they're straight to the point. So that's why we're going to drop this in here as like a link to take a look at. But yeah, I mean, we're not going to go over the whole thing, but people have talked about this plenty. There's plenty of information out there. The other shout out that I've got was from Maxwell Dullen. We talked about last time. He had a house of something. I should have looked it up, but forgot to add this to our list to actually talk about. Basically just another look at a Fastman variant of the House of Mind. Really solid write-up. We've covered him before when he did another heap House of attack. So I kind of wanted to shout this out that it's there. You can go read it. But we're not going to cover the actual details of it, but it is just a variant basically of House of Mind impacts Fastman.
Yeah, I was hoping to quickly try to find what it was, but I couldn't. So unfortunate. But yeah, like it's always cool to see some new House of attacks. But yeah, so that pretty much wraps up all of our topics for the episode. Thank you to everyone who tuned in. You can catch the VODs on Twitch or on YouTube, as well as some other platforms you can find on our Anchor 24 hours after the stream. Follow us on Twitter and check out our Discord for notifications whenever we go live or for whenever we put out other content that we might put out there. We'll be back in next week, though, at the usual time, 3 p.m. Eastern, 12 p.m. Pacific, and we will see you all then.